Hello, here's a demo of QAG or Query Augmented Generation. Let's say I had a query like this for cancer genomics. What is the co-occurrence frequency of somatic homozygous deletions in CDKN2A and N2B in mesothelioma in the Genomic Data Commons? Now, query like this can be answered through the GDC portal, but it would take several steps. Let's take a look at how we can answer this through the portal. So the important components are mesothelioma as the cancer type and CDKN2A and N2B are the two genes that we are interested in. So let's go to the GDC portal. This is our GDC portal. And let's go ahead and type, first look for mesothelioma. So this is TCGA meso. It has around 87 cases. We can go ahead and save a new cohort, TCGA meso. And let's set this as the current cohort. So we can see that there's a cohort of 87 cases made. Now we need to enter our two genes, CDKN2A and N2B. So for that, we can go to the Analysis Center, go to the Mutation Frequency app, and here I'm going to upload genes, CDKN2A, CDKN2B. So when we do that, you see it matches the right ensemble genes. Let's go ahead and hit Submit. So the minute we do that, there will be a lower panel that will come up over here, this one, which shows you for each gene, what are the cases that have homozygous copy number variant deletions. So we can go ahead and make cohorts for each of these genes as well. So let's start with CDKN2A first. So we will call this CDKN2A HomDel for homozygous deletion. Go ahead and save it. And let's do the same for CDKN2B. So let's call it CDKN2B HomDel. Save it. So now we have saved the two cohorts. Now our question is asking for co-occurrence frequency. So we actually want the cases that are at the intersect of these two cohorts because those are the ones that share the homozygous deletion. So to get at that, let's go back to the Analysis Center. And the app that we want is a set operations app. So let's open this up and we see that the cohorts we just made are showing up here. So let's select CDKN2A and N2B and hit run. Now, when we do that, we see that there are 39 cases at the intersect. So that is a number of cases with homozygous deletions in both the genes. And so our co-occurrence frequency is 39 divided by 87, which is the total number of cases in mesothelioma. And that is around 45%. So this is the way, one way to do it through the portal. And as you can see, it has several steps. So now let's look at the tool that we have deployed, the QAG tool, which is, this is our interface for this, and this is powered by our on-prem GPU. So let's go ahead and type the same, copy paste the same query into this window. And so when we do that, there is an agent in the background that works on the tools that we have wired into QAG to generate the plan and hit the correct API endpoints and compute the intersect. So you can see that it is ran in seconds and it's hit all the right endpoints over here, generated the plan and computed 39 cases with homozygous deletions in both genes, which is consistent with what we saw on the portal. And the frequency also matches what we saw on the portal, which is 44.8. So this says that the result retrieved from QAG is accurate. Now I can also run it in an interactive mode. So if I ask it, can you recompute for breast cancer? Then what it will do is it remembers the chat history. It knows the previous question that you asked. So it will hit all the same endpoints. And the only thing it will do is it will switch meso to BRCA because now the question was asking to recompute for BRCA and has shown you that answer here. Thank you.